Hello everyone. In this video, we are going to discuss maximum product subarray question, which is seventh question in our arrays of 75 lead code question. So yeah, let me start sharing my screen. Alright, so yeah, as usual, I'll follow these 8 steps. So let's start by reading the question first. So the question says, given an integer array nums, find a subarray that has the largest product and return the product. Test cases are generated so that the answer will fit a 32-bit integer. Okay, sounds good. So what we do first is figure out what's the input look like and what's the output they want. My apologies. Yeah. So what the input look like and what the output does the interviewer want. So here both of these, the input is a vector of int, and output, if you see, they just want us to return int, and the question already says that this will be taken care of, that the sum of the multiplication of the items of a vector will always be within the bounds of int. So that's good. So yeah, we have input. Yeah, we have input output there. Now, next thing we do is multiple test cases plus edge cases. So yeah, this question, if you see, this has to be a subarray, which means like it has to be a consecutive one. Actually, let me use this. It can't be like we can pick -2 and then -1. It has to be a consecutive one. So yeah. So now let's take some examples. 2, 3, -2, 4. 2, 3, -2, 4. So in this subarray, actually, there's one more thing that they might tell. Yeah, this subarray that in the input, sorry, the array in the input will always be size greater than 1, so we don't have to handle the edge cases of empty array. We'll say there's always something in nums. So if it's empty, we don't have to handle that edge case because input will not be like that. If it's 1, then we're gonna just return the product of that item itself. I mean, just return that index, and it will be that will be the maximum product. And yeah, if anything greater than 1 comes, then we have to write algorithm. And in this one, if we see, this is, say we have to return 6 because 2 and 3 are consecutive, and we cannot return like anything. Like if you see, one negative will make the entire value of the array is negative. So the possible values in the arrays can be all positive values. That means, let's say array has 1, 2, 3, 4, and n number. So in that case, we are just going to return the multiplication of entire array. That will be the max. Second, we can see is what if all negative numbers are there, like -1, -2, -3. And this is, I should say, all even negative number. Let's say -4. There's, or you can say -3, -4, or anything that's even negative number. So then also the entire array will turn out as positive, and we're going to return the multiplication of the entire array, and that will be the answer. Third case is, what if they're odd? What if there are zeros? Let's look at 0 first. What if there are zeros in the array? If there are zeros in the array, let's say -1, -2, 0, 2, 3, then 0 will always make the array 0. So like the multiplication is 0. So the max product either is going to be 0, and or the other subarrays except 0. So if you see in this question, let's say 2 and 3 is going to be answer is going to be 6. We cannot include 0 because if we do, the answer will become 0. Now if you see in this case, -1, -2, 0, -2, -3. In this case, if you see, this is going to be yeah, this is going to be, let's say, -1. This is plus and plus. This is going to be -2 multiplication. This is going to be -6. Now in this case, both of these are smaller than 0, because when multiplied by 0, it will become 0. So what we'll do is, like, we'll pick up this one or this one and say, all right, 0 is the maximum. So in 0, there are two cases that basically whenever 0 comes, we have to figure out the left what's the prefix and the right suffix. Prefix and suffix are the 0, and if we see if they are negative, then yeah, we return 0. If not, then yeah, that's going to be the maximum itself, because if it's positive, then we should exclude 0. So that's one edge case that we have to figure out. And the last edge case I see is, like, we did even negative, we did all positive, we did 0. Next is, what if we get odd negative numbers? So let me take an array, for example. So let's say 3, 2, -1, 4, -6, 3, -2, 6. So this is an array with an odd number of this one. So if you see, if we try to divide this one, either the answer will be, for every negative number, we have to check the subarray on the left and right. So this, for, let's say, for -1, because if there are 3 negative numbers, then one of the subarray with 2 negatives should be the answer. So basically, if you look at this way, let's say -1, this is 6, and this is like, let's say, big 24 into 3 into 12. That's the answer. And because 2 negative, so it's going to be positive. Then if we come at -6, both the sides have negative value. One negative here, one negative here. So in this case, we will include -6 also and say, okay, both are negative, -6 will make them positive, and see what the answer is going to look like. And third case is -2. So where the right one is 6 and the left one is 3, 2, -1, 4, -6, 3. So basically what I'm trying to catch here in all these examples is a pattern that for every value, if we know the prefix and suffix value of multiplication, then we can, at every index, we can decide what's going to be the maximum product. And yeah, let's say, let's take one more example. Let's say -2, 3, 4, -1, 0, 2, -2, 3, 1, 4, 0, 4, 6, -1, 4. Now, as soon as 0 comes in, there are two cases, right? Either the max product should be 0, because if all the subarrays present have negative multiplication. If not, then yeah, whatever has, like in this one, let's see, this one has 2 negative sign, which will become plus. So this will become 4, 12, 12, 24, 20 plus 24. This one has plus 24 too, and this one 16, 16, 24 into 4, 92, 92, minus 92. This is negative, so this is not even considered. But we are not going to consider 0, and we are going to just return answer as plus 24, because 0, if we include, it will always make entire value as 0. But because one of the subarray has 24, we'll do that. So the pattern here that I'm catching is, if we can figure out each possible subarray, and on each left side and right side of each value, then it's easier for us to decide. So yeah, let me run an algorithm through this code to show you guys. So let's take 3, 2, -1, 4, -6, 3, -2, 6. Yeah, so this will be max value, and this will be what should be current product. So this will start from 1, and this will be int min. So let's start with I equals to 0, and at every step what we're going to do is, first we're going to multiply the ith value with the current prod, which is 1. So when I equals to 0, this is 3, so current prod will become 3, and at every iteration we'll be like, all right, Maxwell, which one is bigger, this or this? 3 is bigger, so we'll update this. Then for I is equals to 1, we'll say 3 multiplied by 2, which is 6. Which one is bigger? It is 6. For I is equals to 2, we'll take 6 multiplied by minus 1. This becomes minus 6. And which one is bigger of this? 6. So the thing is that with max subarray of product, we cannot just ignore negatives. We have to keep taking these forward, because you never know when this negative can turn into positive if you find a negative number. So for I is equals to 3, we'll do minus 6 multiplied by, let's make this 0 to demonstrate an example. I equals to 0, 0, 1, 2, 3, 4, 5, 6, 7. Yeah, so for I is equals to 3, the value will be minus 6. So this will become 36, and which one is bigger? 36. This will be updated. And then this is the tricky part. When I equals to 4 comes, this will turn, oh my bad, 3, 6, minus 6, 6, 4, 24. This will be 6, minus 24, sorry, this is 4. Yeah, 6, 4, 24. Yeah, when I equals to 4 comes, then minus 24 multiplied by minus 6, which will become 120 plus 24. 144 of negative. Actually positive, because minus 6 and minus previous sum will be this, and then this will be 144, because previous was 36 and 144 bigger than that. Now when I equals to 5 comes, this will become 0. That means that any subarray behind this item does not, this subarray value is 0. And then what we're going to do is, like, the trick part here is that whenever we face I, we just turn this value to 1. Whenever we face this as 0, we'll turn this value to 1 and just move forward, because we don't want to carry 0 forward, or else all the product in forward will become 0. Then for I is equals to 6, we will be saying, all right, minus 2. 144 will stay. I is equals to 7. Let's say minus 2 into 6, which becomes minus 12, and it stays 144. So clearly in this answer we can see that the answer will be minus 144, because of this array. And yeah, but we also have to do the exact same code for suffix. What if the answer was, what if the question was 3, 2, minus 4? Let's see this, 0. Actually, let's do this, minus 2, minus 4, 0, 3, 2, 5. In this case, this one's gonna be the answer, right? So if we take this, like, follow the prefix method, will be saying, all right, minus 2 will be the max value, then it will become 8, then it will stay 8 when it's here, then it will become 3, then multiply 2, multiply 5, this will become 30, and then we should replace that. Yeah. So okay, let me code this algorithm for you guys now, and let me see. So let me code this. So we are taking two values. It will start with int min, because nothing can be smaller than int min. Then we are starting, let's say, current product, which will start from 1, because yeah, nothing's going to be in the back. Then we're gonna what we're gonna do every time we come here, we're gonna say current prod star equals to nums I, and we're gonna say if max val is smaller than current prod, that means there's a new maximum. So we'll say max val is equals to current prod, and then the thing about 0. If current prod ever becomes 0, then change the value of current product is equals to 1. Now this code is for prefix calculations from the left to right, right? Because every time, like if we looked in the questions that we have to calculate prefix and suffix for each item, then now let's run another loop. We are going to say current prod is equals to 1 back here, and then we're going to say int j is equals to nums dot size j greater than equals to 0, j minus minus, and then we're going to say exact same thing, current prod star is equals to nums j if maxval is less than current prod, maxval is equals to current prod, and same if current prod is equal to 0, current prod is equal to 1, same exact same thing. And then at the end of the code we're going to just return current prod. Now this algorithm should work. It's, if we look at time complexity, we are just running a loop for n time, another loop for n time. So big of n plus n becomes big of 2n, so big of n. And as far as space complexity is taking, we are only taking two variables, so this should be always 1. Now let's code this algorithm out. So actually let me just show you that quickly. Yeah, so if you see, let's copy this code. Yeah, so if you see, product we initialize as 1, max product we are taking starting from min, then we are going from left to the right, and then every time we are multiplying this by 1, then we are taking max product, max of the max product and the current product that we are taking. If product becomes 0, we're going to make it 1, and then we're going to go for suffix. This loop is for prefix, and this loop is gonna be for suffix. And yeah, once we calculate all the prefix and suffix, and each time we are taking max product, we're just going to return that. And let's submit this. And yeah, big of n time complexity, this works. I would suggest try writing more edge cases and running this algorithm on those edge cases to understand the solution more. But yeah, this is an efficient solution, and let me know if you have any questions and comments. Thank you.